talking a little bit about aerodynamics. Talked about aerodynamics in other segments, but wanted to talk a little bit about Bernoulli's principle, connection to aerodynamics. We were flying planes the other day. If you've got a wing at a particular angle, you can get a lower pressure on the top versus a higher pressure on the bottom and get the lift that you need. Again, the forces on the plane, the simple forces we talk about are thrust forward, drag, opposing, weight, or mass times gravity downward, and lift upward. So we need thrust and sufficient thrust to get us the lift, so we need an angle for the wing and also sufficient thrust forward so we can get that plane. That didn't go too well. We want to get it off the ground. By the way, the space shuttle has some booster rockets that launch it into space, or actually into orbit, actually falling toward the Earth in an orbit, not necessarily gravity-less environment, so it's in an orbit in the Earth, but needs a lot of thrust to get off of the ground, and then on its way back it glides. So we need to have aerodynamics here and basic space mechanics here. Okay? By the way, when you're in outer space, you don't need to worry about aerodynamics because there's no atmosphere. You just need to have thrust to move you from one place to the other. Okay, but if you're trying to fly through a fluid, in this case the fluid being a gas, we need to worry about aerodynamics. Bernoulli's principle, low pressure air versus high pressure air, faster moving air, low pressure, slower moving air, high pressure. Got a tube here, we've got the hair dryer. If I start up the hair dryer, I have a stream of air. It's going to be faster flowing air versus the surrounding air. So it's going to be lower pressure. So faster means lower pressure. Slower meaning higher pressure. So higher pressure will be surrounding it and everything will be sucked into the jet. So here I've got my hair dryer and a ping pong ball on the string. Well, actually I don't really need the string. And it will stay in the jet. And you can tip it pretty far. Pretty neat, huh? So that's Bernoulli's principle, at least a simple demonstration of Bernoulli's principle. If we extend the stream, okay, let's see what happens if we extend the stream. Oh, okay, so you extend the stream, the same thing operates. So we talk about Bernoulli's principle in connection with Newton's third law, action and reaction, to get the plane some lift. And of course we have lift in terms of propellers thrust forward or helicopters going from lower to higher. So helicopters have a lift incentive as well. This is kind of a neat one. Here you've got a propeller, all right, or in this case we'll call it a helicopter blade. Propellers and helicopter blades the same, where the air is going to be going through this blade and coming out. All right, so this is Newton's third law, action, reaction, gets it to turn. And you see the angle on the blades, all right, will allow for lower pressure on the top, higher pressure on the bottom. You'll get the lift that you need. So we're going to blow up a balloon, hook it to the propeller. All right, so here is our energy source. All right, so we've got our pressure here, hooking it up. Actually, let's try this one here first. Well, that one went there, but let's try this one. That balloon was kind of a weird shape. Okay, let's hold this off. And as it spins faster, it generates more lift. So here we go. Oh, wow, out of the picture already, and there it comes back down. Here's another way we can do the same thing. Another propeller, or helicopter blade, if you will. It's the same thing, operates on the same principle. We're going to get this to spin fast enough. The tilt angle of the blades, lower pressure on the top, higher pressure on the bottom. Probably get this to go right at the camera here. And there you go, wow, kind of neat. So Bernoulli's principle in connection with Newton's third law, action and reaction. And that goes for any kind of blade. A fan blade, if you want the air to go forward or backward, depends on the angle of the blade. Okay, so whether you're angling it in such a way to get the air to stream backward or to blow at you, it's going to be about the same concept. All right, so one other thing, you might want to try this one, kind of a neat one. Get a long tube, put a funnel at the top. If I put a ping pong ball in here and say, I wonder if this person can blow the ping pong ball out of here just by blowing on the end of the tube. Most people think all you need to do, and I'll take the ball out, is blow, and the ball will shoot right out. Is that really true? Well, if you know something about Bernoulli's principle, as you blow in the tube, you've got a stream of air. But you put the ball in, the ball is going to have an interaction with that stream of air. And the air near the bottom of the ball will be going faster versus the air on the top of the ball. So again, remember, lower pressure air is going to be the result of the faster air. So faster at the bottom, lower pressure, slower air at the top, higher pressure. Higher pressure pushes into lower pressure, so the ball is actually trapped. So you can blow on this all day, and you can't get it out. Like this, I'm going to put another ball in here just to show you. Doesn't matter, another ping pong ball. You can blow until you're purple in the face. Now, can you actually get this ball out of there? Yes, by knowing something about Bernoulli's principle. If I blow across the top, I've got a faster moving flow of air, lower pressure. So it'll be lower pressure here, higher pressure is going to push, whoops, right over the top. See? Really neat, huh? So you can't blow it out, but you can use Bernoulli's principle to blow over the top, and there you have it. So I'll see you in the next segment. Take care. Try it out.